show that the three lines whose equations are given to us are concurrent. That means they have a common point of intersection. Okay, let us begin. So first what we'll do, we're going to name each of the three lines. So let's say the line L1 has got the equation 3x minus 5y minus 11 equals to 0. Then we have the next line denoted by L2. So L2 has got the equation 5x plus 3y minus 7 equals to 0. And then we have the third line L3. L3 has got the equation x plus 2y. So here we do not have the constant term, so let's write 0 here. So this is going to be equals to 0. Now we have three lines L1, L2 and L3. Let's form the determinant. A 3 by 3 determinant will be formed. So all we have to do is in the first row, we're going to consider the coefficients of the line L1. So we have coefficient of x, that's 3, coefficient of y, that's negative 5, and we have the constant coefficient term, that's negative 11. Then in the second row, we're going to consider the coefficients of line L2. So we have 5, 3, and negative 7. And then finally, in the third row, we consider the coefficients of line L3. So we have 1, 2, and 0. Okay, what we'll do, we're going to expand this determinant along the first row. So let's consider the first element in the first row, first column, which is 3. So 3 is going to get multiplied to a 2 by 2 determinant. This 2 by 2 determinant can be found by rejecting the row that contains 3. That means we're going to reject the first row and also reject the column that contains 3. That means we have to reject the first column as well. So that leaves us with 3, negative 7, 2, and 0. So this is how we form the 2 by 2 determinant. Coming to the next term, we need negative of the element present in the first row, second column, which is negative 5. So that also is going to get multiplied to another 2 by 2 determinant. The determinant can be obtained by rejecting the row and the column that contains negative 5. So we're going to reject the first row and the second column, which leaves us with 5, negative 7, 1, and 0. Then finally coming to the third element, so that is going to be positive. Now here we have negative 11 in the first row, third column. So we're going to take negative 11 and multiply it to the 2 by 2 determinant formed by rejecting the row as well as the column that contains negative 11. So we're going to reject the entire first row and the entire third column, leaving us with 5, 3, 1, and 2. Now we're going to expand each of the determinants. So we have 3. 3 is going to get multiplied to, so we have 3 times 0, that's going to give us 0, minus 2 times negative 7, that's negative 14, but we're going to get positive 14 since we already have the negative number. Negative times negative 5 makes it positive 5. So 5 is going to get multiplied to, so 5 times 0, that's 0. Then 1 times, this is negative, 1 times negative 7 makes it positive 7. And then we have negative 11 multiplied to 5 times 2, that's 10, minus 1 times 3, that's 3. So that's further expanded. So 3 times 14, that's 42, added to 5 times 7, that's 35, minus, so we have 10 minus 3, that's 7. 7 multiplied to negative 11 makes it negative 77. Now clearly, 42 plus 35, that's going to be equals to 77. So 77 minus 77, that's 0. As we are getting the determinant equals to 0, so here we can say, thus the lines, the three lines that we just that we considered, L1, L2, and L3, these three lines are going to be concurrent. That means they are going to pass through a common intersection point since the determinant came out to be 0.